are going to be talking this chapter about perimeter and area of all the different figures we've been talking about, from our triangles to parallelograms, other quadrilaterals, circles, and even regular figures. So we will be looking at all of these different things. It's going to be kind of a short chapter because we're going to take a few sections out, just time-wise. We're running out of time. And we're going to kind of condense 2 sections into one day. So this chapter is going to go pretty fast. We're looking at learning new stuff this week, a little bit next week, and then we're going to end next week with the test. So just kind of giving that warning ahead of time. We're going to start with the figures that we already know. Most of today will be review, but it'll be a good review. So we're going to start with our joke of the day. So our joke today is, what do you say when you see an empty parrot cage? Polygon. Okay, we're going to start today with a rectangle. Like we said, this is review. We've already used finding the area of rectangle during the year, but we're going to make a little change in how hopefully you guys look at it, because all of the rest of the area formulas that we're talking about, different figures, are kind of based on this one. So normally we would look at a rectangle and we'd say, okay, it's a length times width. But I want you to, in your head, think instead of base and height. Okay? Because we've used base and height, we used it for triangles, we're going to use it for all the rest of them. And if you think of it this way, you might be able to picture how they're all related. Rather than trying to memorize a bunch of formulas, you just kind of remember how the figures are related pictorially using the same terminology, and it might hopefully kind of click and help you remember all this stuff. Alright, so instead of doing length and width, we're going to look at the base and the height. So the base is going to always be the horizontal length, and the height will be the vertical length that we're talking about. So everyone pretty knows length times width, but this time we're just going to say our area is base times height. Base times height using the horizontal times the vertical. Height is always going to be perpendicular to our base, which is nice when we're dealing with a rectangle, because that's always true. So we'll do like a little example here. We have a rectangle and we have a length 12 and the base is 12, the height is 15. So using our formula, we know it's going to be area equals 12 times 15. And we come up with, and I don't remember the number, 180. There we go. So our area is this. If we have meters or centimeters, remember that when we're dealing with area, your units are going to be squared. Going to have squared units. Okay? Let's look at another kind of rectangle. Okay, hopefully you already all guessed that when I said we're talking about another rectangle, another type of rectangle, you already know we're talking about a square. If you remember from our quadrilateral section, the square is always a type of rectangle. So again, we can start with, since it's a rectangle, we just learned that the area of a rectangle is base times height. So a square is a right angle, has 4 congruent sides, but it does also have a base and a height. But again, as a square, the base and the height are congruent, so most of the time they're going to go ahead and just say, alright, we're going to call our sides S. So the area, since the base and the height are the same, are S times S, or S squared. The area of our square is S squared. But again, since it's a rectangle, if you already know this, then you're fine. You just remember base times height, and you'll be fine. I'm not going to ask you to do them separately. Alright, so pretty straightforward. If we have a square whose sides are all 4, then we know that the area is 4 squared, or 16. Straightforward. Okay? Alright, so now we're going to look at a new one. This one comes basically from the area of the rectangle, and look at my example here. It used to be a pretty good example, but not many people have CD cases anymore. But I want you to think of this as if we had stacked a bunch of CD cases on top of each other. we could find the area of the fronts of those CD cases by looking at the base and the height, using our area equals base times height. But what happens if I took those CD cases and kind of leaned them this way? So now I've got a parallelogram. The question is, did I change that front, that area that I had in the front, did I change it just by moving it? And the answer actually is no, I didn't. So the area is the same. The thing that changed is here, my height now is still going to be that perpendicular distance from here is still the height times this. So our formula is actually going to stay the same. Area equals base times height. But notice we have this new length here that they're going to give you, the length of the parallelogram, but that's not going to be my height. Remember, my height has to be perpendicular to the bases. So when you're dealing with a parallelogram, you're going to look for that parallel height or the perpendicular height that they give you here. So here's my base, my height is still here. So let's look at an example of a parallelogram. Most likely they're going to look like this. They're going to give you the base, and over here somewhere they're going to give you a height. But they may also give you this side here. So if they tell you, all right, this is 10, this over here is 12, and the height here, we'll go ahead and make it, let's need to go, let's make it a little bit smaller. Let's make this one 10 and this 9, right? They're going to expect you to pick the right numbers, okay? So always know when you're doing the area base times height, it has to be the two perpendicular. So we're not going to go 10 times 10. We're going to know our area is 10 times 9 because those are the two, height and base, to be 90. Okay, so that one's new, but again, it's the same formula as we have as the rectangle. So we haven't gotten a new formula yet, but we will now. Okay, here's question 1. I want you to tell me, how do you find the area of a parallelogram? Write it down for me. Okay, let's look at our triangles. They're very familiar. We've actually been doing area of triangles for a long time, but I'm hoping again you kind of see where the formula comes from rather than just memorizing it. And by the way, all of these formulas are either some theorem or postulate. You still need to put them in your notebook, but I'm not going to ask you for them as a theorem. We're really kind of looking at them as formulas. So that's why I want you to treat them. All right, so let's look at our triangle. We've studied earlier. We know, actually, I probably already remember, the area equals 1/2 base times height. But why is that true? That was kind of what I wanted you to see. All right. So we have from here, this is the base of my triangle that it's sitting on. The height, again, is going to be that perpendicular distance from the vertex straight down to the base. That's where we get our base and our height and our formula. But I want you to think about it. Every triangle we can actually show is half of some parallelogram. So if we continue this, let's draw this triangle, flip it around, and connect it over here. We can see this is a congruent triangle that we've flipped around, and boom, we have parallelogram. We know, again, we just learned the area of the parallelogram is base times that height, and we showed that our triangle is 1/2 of that base times height. Let's look at another type of triangle. We've been looking at right triangles. This one's even easier to see if I draw the congruent triangle and flip it over. We have a nice rectangle. If I drew it a little better, there we go. Again, area of the rectangle is base times height. So my triangle, and we'll probably put a little area of the triangle, is 1/2 base times height, where this is my base and this is my height. And even the obtuse triangle here, you can show when I take it, flip it over, we're still going to have that parallelogram. These are the same here. 1/2 base times height. Remember, they put the height out here most times. or here's my height and here's my base. But that's why we actually have the formula of 1/2 base times height, because every triangle is some kind, half of some type of parallelogram. Let's do a couple examples. Okay, here's a few triangles I wanted you to look at, different special ones we may have done in the past, but I want you to re-look at them again. So here we have a 5, 12, 13 triangle. Often they're going to give you more information than you need. So you're looking again, we're going to do 1/2 base times height for our formula. So our base and our height are always going to be perpendicular. So here we're looking at the base and the height. When we fill that out, it's 1/2 times 12 times 5. And when you do that, you're just multiplying straight across. So you can go ahead and take half of the 12 to be 6 times 5 or 30. Okay? And this one here, again, they give us more information than we need. Do not assume it is a side. Remember, it's a right triangle. The height does happen to be the other leg, but this one's obtuse, so my height is outside here. Be careful, sometimes they'll put heights inside your figures. This one often is outside. This one, 1/2 base times height again. This time our base is the 8 inches. Be careful, don't use the part that's outside your figure. Even if they give you a nice number there, just go make sure you're dealing with the base is always the side of your triangle. And our height this time is the 4 because again it's perpendicular. So 1/2 times 8 times 4, you can take half of it to get 4 times 4 or 16 inches squared. If they give you units, go ahead and put them. Sometimes they won't, you're just dealing with the numbers. Okay, now let's look at working backwards. Alright, let's work this problem together. Let's read it. The base of a triangle is 1/2 the height. The area of the triangle is 64 square centimeters. Find the base and the height. So as usual, please draw a picture. I know we don't know what kind of triangle it is, but it just helps us get our numbers in the right place. So we're just going to draw a triangle where we have a height and a base shown. We know the base is 1/2 the height, so if this is my height, h, then we know my base is half the height, or 1/2 h. Now we don't have two variables, and this is going to help us solve our equations. We start with the formula, or start with the amount. We know the area is 64 square centimeters, and we also know our formula is 1/2 base times height. So we're going to put the amount of our area on the left side. Let's substitute that. Area is 64. We know the base from over here is half of our height. And then we're using h for our height, so we can just leave him there. We're going to go ahead and multiply what we can. Let's kind of combine this together. We have 1/2 times 1/2. Everything is times, so we just multiply across, multiply our numbers to be 1/4, and we have h squared, h times h equals 64. And we multiply both sides by 4 to get rid of our fraction. And we wind up with 256 equals h squared. One key, whenever you have a number and a variable squared, you cannot square it until it is by itself. So make sure you get rid of your numbers before you take the square root. Even though you look at that and go, oh, we can take the square root of 64. You got that 1/4 over here. It's not going to be pretty. So go ahead and move the 4 over. Then you can have h squared by itself. We're going to take the square root. Square root of 256 does happen to be a perfect square. If it's not, put it in simplest radical form. Unless it asks you to give a decimal answer or a real world answer, then you can give me an amount. Okay, so here we have, take the square root of both sides. We know our height is 16. Square root of 256 is 16. But remember, we're not finished. Let's go back and see. We're supposed to find the base and the height. The height is 16. They told us the base is 1/2. So we know our base is half of 16, or 8. Now we're done. So start with the answer equal to your formula, and then use whatever the information they give you to fill in or substitute for the base and the height. Okay? Okay, now we're going to kind of put everything we've learned together here at the end of this section. We're going to talk about two postulates that are not formulas. I just want to mention the first one tells us that if two figures are congruent, they have the same area. That one, again, hopefully is pretty obvious. Therefore, it's a postulate. But the next one, obvious but useful. We talk about the area addition postulate, which tells us that if we can find the area of separate parts of our figure separately, we can add them together and get the area of the whole piece. So that's what we're looking at. And yes, we don't have a formula for this little five-sided figure to find the area, but we can find the area of our triangle plus the area of our rectangle and add them together to find the area of the whole polygon. Okay, so now this one's going to put a couple things together. Hopefully you'll notice, all right, I got a rectangle. Let's kind of get him out of the way. We know the area of our rectangle is base times height. We have a base of 30, height of 9. So we're going to go 30 times 9. So the area of my rectangle, I'm going to put like a little r here. That's the area of my rectangle. 3 times 9, so we get 270 feet squared. Let's make that a 2. Okay, feet squared. Now the triangle, we know we need 1/2 base times height. But hopefully you look at that and go, okay, I don't have the height, but I do have an isosceles triangle. And if y'all remember isosceles triangles, we can find the height if we drop our altitude down here. Okay, make it perpendicular to the base. Since this is lined up, this base is also 30, same length as the base down here. So we have our base. Now remember, the altitude of the isosceles triangle, when you drop it down, cuts our base in half. So we know this is 15. And then we have a nice little right triangle. Using our Pythagorean theorem, we can find the height of our triangle that we're looking for. All right, so we're going to kind of do that as an aside. We know that h squared plus 15 squared is going to equal 38 squared. I'm going to go ahead and move my 15 over there. H squared equals 38 squared minus 15 squared. You get out your little calculator, figure out 38 squared minus 15 squared was 1,219. And now h squared by itself, we're going to take the square root. In this case, we're going to use a decimal. We don't really want to deal with square roots in a real world area problem. So we're going to find that it winds up being about, with our little about sign, 34.9 feet. That's what we're dealing with, feet. All right, so now we have our height is 34.9. I'm going to have to rewrite that one, 34.9. But now we can find the area of our triangle. So these ones are going to take a little bit more work. You're going to have to find each piece separately, and at the end we're going to add them together. Area of my triangle is 1/2 base times height. Just don't get everything mixed up if you use double variables somewhere. My base for the triangle is going to be 30. Don't forget we go back to the 30. My height is 34.9. And when I multiply straight across, half of 30 is 15 times 34.9, we get 523.5 feet squared. And then our total area, we're going to add everything together, 523.5 plus 270. Our total area winds up being 793 point, I guess I shouldn't lose the point, 0.5 feet squared. There's our answer. Okay, let's look at one more again, how we break these apart. So look for figures that you already have an area formula for, and it's not always going to be the same one. Some people will see different figures depending on how it's cut. But they should always add up the same because of that postulate that tells us that the separate parts that we find the area to, we can add them together to find the total area at the end. Okay, I want you to look at one like this situation here. When you look at it, they may or may not have that line there, but they're asking you to find the area of the shaded part. They're going to use shading a lot. So if you look at this, we don't have a nice shape that is shaded, okay? So the area addition postulate works the other way too, where you can say, all right, I can subtract an area from an area that I already know. So if you look at this, you might notice, okay, I've got a rectangle, and I can find the area of a rectangle pretty quickly. And what I have, the piece that is cut out, is a triangle. So we also have a formula for the triangle. The question is, can we get all the parts we need, right? So this time, I'm going to look at this as a whole piece. I'm going to find the area of the whole thing and then subtract the triangle. So the area of my rectangle, area of R, or you can write rec or whatever. Area of the rectangle we know is base times height, and here my base is the 38 times 15. So the area of the whole rectangle, including the white part, is going to be 570 centimeters squared. Okay, and then the idea is, can I find the area of my triangle? Now since it's a rectangle, we do have the same base up here. It's just upside down, right? The base of my triangle, and then I need to know this height. Now they wind up giving us the height over here. They told us the whole thing's 15. Okay, so if that's 15 and they told us from here to here is 8 centimeters, that means this has to be 7 centimeters. And there's my height of my triangle inside, because they kind of will match that up here. So the area of my triangle is 1/2 base times height. So my base again is the same 38 centimeters. And my height is going to be the 7 times 7 here. So we wind up multiplying across 1/2 times 38 times, I lost my place, times 7 is 133 centimeters squared. So then at the very end, when they ask you, we're not going to add them together, right? Our total area this time is going to be the 570 minus 133 centimeters squared to give us 437 centimeters squared. Alright, I just wanted you to see one where they actually remove part of your picture, part of your figure. See how we do that. Okay, now the next one's going to be your question number 2. I want you to try one for me. Okay, here's question number 2. I want you guys to draw it, give it a try, and you're going to find the area of the polygon. So notice we have a whole polygon here. We've got a rectangle and a triangle. They tell us from here to here is 20, from here to here is 15, and from here to here is 25. We have a nice little right triangle there. So I want you guys to give this a try. Find the area of the whole thing. Alright, so I'm not going to do it for you. I want you guys to figure it out. And we're going to finish up section 1 here. We'll see you next time when we're finishing up some more area of new figures, looking at our trapezoids and kites. So, see you soon.